Hello, everybody, and welcome to Unacademy classes. My name is Abhishek Mishra, and in this class, we will be discussing about the important questions and some of the important concepts in the thermodynamic subject. And we will be doing a revision, a nice quick revision, where we will be discussing some concepts and doing the questions from that concepts. So, since GATE exam is around the corner, so this is a revision series where we will be moving in a very rapid pace, but at the same time I will make sure that I am explaining all the things that will help you out. So without further ado, let's start the class. So first of all, I am taking this entire class in English, and before I start taking this class, let me open the chat section so that I can answer all your questions and doubts that you have during the class. And I urge everybody to just visit this class or watch this class live, or to attend this class live, so that you can interact with me and you can answer the questions that I'm asking. And overall, you will find that you are better prepared and you are taking more from the class if you are watching it live. So I'm recommending you to just watch this sessions live. And let's continue our discussion that we were doing from yesterday. And let's start the class. So first of all, I'm going to introduce myself. I have secured All India rank of 662 in GATE 2020. I've completed my MTech in 2019 from IIT BHU Varanasi. I've got 2 years of good teaching experience in mechanical engineering subjects. Some of my interests are photo editing, video editing, cricket, football, and I like all sorts of games. So I have prepared for GATE exam. I have also taught it. So over the years, I have accumulated a lot of tips and tricks that I'm sharing with you, and that I also shared if you have watched some of my series that I took in this channel, such as I recently took, I think tomorrow only, not tomorrow, yesterday only, I took a class where I discuss about some common mistakes that a students make a student make and how to avoid them. And this was based on the manufacturing subject. So I will be taking a similar class in the thermodynamics topic, and I am making sure that first of all I have completed, I will try to complete a lot of things in this month only from the thermodynamics subject. And let's start the class. But we also have to here discuss about the Unacademy subscriptions. And first of all, if you have not downloaded this app, just download this app. This app is absolutely free, and this is high time you download this app, because if you are not yet downloaded this app, then you are missing on a lot of things. And this time, that is just 2 months before your GATE examination, a lot of new revision classes and crash courses are starting, and I recommend you to just check out the website of Unacademy and see all the courses and attend all the courses and revise using that courses, and watch the courses live. Don't watch recorded session, because even though it is good, but the things that you can get from the live sessions are far better than what you are going to get from the recorded sessions, because there you will be watching a class live, so you will be obviously a lot more attentive. And if you want to watch my classes on unacademy.com, I am taking some exclusive questions there. And yesterday only I took some of the important questions on the Unacademy's website, and one of those particular questions was very good. And one of the student who was watching the class, uh, he also just he was doing all the questions good, but that question just he found it tricky, and then we solved it together and we found that the question had a lot to offer. And we will be doing that questions, such questions which are tricky and which will be giving you a lot of info here on YouTube also. But the hard, important, tricky questions one after another, if you want to see, then visit me, follow my profile, and attend my classes on the Unacademy's app or website. and here is the link. Just copy this link or just write it down on your browser, and then you will find that you are taken to my Unacademy profile where you can follow me and watch my classes there. And if you are not have this if you not have this code, then you can just write it down to watch the free classes on Unacademy, and also to download the notes that I and other educators are teaching from. So you will have this option to download the notes and watch free classes, and to get this taste of what Unacademy offers. So I have to also tell you about this very important thing about what Unacademy subscription gives you. So let's quickly go through this. Daily live classes, live test and quizzes, structured courses, unlimited access. So classes will be held daily. So if you are joining Unacademy's class or subscription, then what you will be getting, you will be getting your live classes from the moment you have joined, and there you can ask your doubt, answer polls. Overall, the one thing that I would just say here is that the Unacademy website is a lot more education friendly than YouTube, because the tools provided by Unacademy is far better than anything you can see on YouTube. There you will be given live quizzes, live polls. The educator, that is me and some other educators, all the other educators have this option to directly see on the chat, not like this seeing the chat on a mobile phone. So we don't have to do this type of things. We just have to teach you with all the tools available on the screen itself, and you also can answer polls, ask doubts, and download notes. So all these things makes the Unacademy website a lot better for education purposes than YouTube. And it is obvious because Unacademy is mainly designed for education purposes, unlike YouTube, which is a general video streaming site. And there are live quizzes, and the quizzes in the Unacademy's app is very good. You will find that you have not done that type of quizzes anywhere, because it is not just traditional type of test and quiz. Traditional quizzes are also available, traditional tests are also available, which are there in the format of your GATE exam. But if you want to do some quick quiz, for example, there is option for doing a quick 5-minute quiz, 10-minute quiz. So that things will help you always keep engaged, because sometimes what you do, you are studying a theory for 1 hour and 2 hours, and then you want a quick break and from the theoretical sections, and you can find that quick break by doing a nice easy relaxing 5-minute 10-minute questions, and then you can continue your theoretical study. So that things will help you a lot, and these are the small things that you have to check out. You have to try firsthand to see what they are and how they are improving your performance and helping in your studies. And the courses there that are taken by the educators will be very structured, so you will find all the courses in a very well progressive manner, which is not there in YouTube. In YouTube you generally find courses scattered. So this is not the case for the Unacademy's website. Unlimited access of content will be there. For one subscription you will be getting live classes or the archive classes, recorded classes in the Unacademy's website, and also test series, quizzes, competitions. All these things are there on the Unacademy's website for you to take benefit of. And the prices of Unacademy are very reasonable. Here are plus subscription price. The code is there for you to get 10% extra off, and here are the least possible price, minimum price in which you can get an Unacademy subscription for. And again, you should select 12, 18 and 24 months, because these are giving you the most amount of discount. But if you are selecting 1 month just to check out, that is also fine, because then you can try it and then extend it if you are feeling that this is helping you a lot. And believe me, save money, join the 12, 18 or 24 months, because this Unacademy subscription will help you a lot. And by choosing this more months, you can save a lot of money. And don't forget to use this code. I am pointing this out again and again. This is giving you free classes, free notes, plus this subscription classes, subscription notes 10% discount, and all the competition recently Unacademy combat is going on. That competition, to join also you need this code. So this code will come in very handy, and I recommend you to just write it down in your copy. And this is universal code, so not only you can use this for GATE examination, you can also use this for other examination, and also multiple students can use the same code to avail the benefits. And you can watch a class with your friends, so that you both can study and both can discuss what the classes have taught, and both can have a nice discussion, learn together. So you can do that also by using this code. So no cost EMI option is also available if you are going for 6 months or above, and that is also a nice one to have. And there is iconic subscription also for those who need more assistance, personal coaching, personalized test series, and this is the minimum price in which you can get an iconic subscription. ABHIMI, same code, 10% off here also, reasonably priced. Iconic subscription are also reasonably priced, because the things that you are getting in iconic and plus are very well worth the cost that is asked. And just see the download the app, check out what they are offering, just use this code and check out for yourself that what you can get in Unacademy. And just after seeing that, you will see that the things that offered by Unacademy will improve your performance a lot. And if you are investing time here on the GATE examination preparation, then prepare from the best, use all the resources, and spend the money if you have to get this subscription, and prepare in a satisfactory manner. So that's it for the Unacademy subscription talk and discussion about the free classes there. And now let's start the discussion that we little bit of this information I shared in my previous class, but in today's class what we will do, we will talk about some of the discussion that we had previously. And then what we do, we will do this questions that I selected for this class. So first of all, our first topic to discuss for the day is non-flow work or boundary work or closed system work. And to begin with, let me tell you what closed system is. So closed system, quickly in one line, it is a system where only energy interaction is taking place, no mass interaction is taking place, so mass of the system is constant. And therefore the work will be called as non-flow work or boundary work. And I am going to draw here a PV diagram and going to give a formula which we will use to calculate boundary works. So this is your PV diagram. Pressure, volume, and if a process 1 to 2 is happening, that is if state 1 to 2 is being changed, then let me draw here from other pen so that we can understand clearly. So for a small volume dV and at constant pressure P, we are going to have this amount of work. So what will be your work done here? Your work done will be del W will be, why del W not dW? Because del W, because the work is inexact differential, and here it will be constant pressure into this small volume dV. And if we integrate this, then we will find this W is equal to integration of P dV, and this work is your boundary work or non-flow work or closed system work. And we will talk about what this work is for different processes. And this formula is only used when you are using this assumptions, closed system, that is only energy interaction is taking place, no mass change is there in the system, and quasi-static or reversible processes. So this is in very basic small term I am talking about. I am making sure that we are discussing this in a manner that we are just getting the information and doing the questions. I am not going in detail very much because this is a revision class, and deep theory I expect you to study from the your notes, but the things that I am going to teach you here will be, I think, will be sufficient to do the questions of the GATE exam. But some of the theoretical things will still be left, which I think is not that important. But since this is that are on your syllabus, then therefore I recommend you to just quickly go through in your theory. But this is the thing that I if you have not yet studied about this thermodynamics, then also you will find the classes very well, because I am going to explain in each and every formula that we are going to use and where we are going to use that. So you will have your about 90% things covered or 80% covered from the topic that I am teaching you, and little bit of theoretical things will be left, and that I think you can do for yourself, or I can do when I get a chance to teach the full thing. But right now you have this boundary work, which is W, and it is equal to PdV integration, and this P is your pressure and dV is the small volume V. And if we integrate, then we will find that we have to go from 1 to 2, that is V1 to V2, so that we can cover this whole process volume. And that's why the integration side is there, and this is for closed system and quasi-static or reversible process. So let's see what this formula will have its use, and what are the non-flow work for some of the most common processes or some of the processes that we have to study for the GATE examination. So before doing that, let's go through these points that we talked about in the previous class, and again we will quickly go through them. So area under the PV curve on a or area under a curve PV represents work interaction for a closed system. So the area that is below this curve 1 2 is providing us the work done or work interaction. So let's say that we have this area under this curve, this is the area. So this whole area will be, that is again the area will be length into breadth, and you can see that these two units x and y are P and V, and this are when multiplied will give you this area, that is the work done. So the other point here is work interaction is a path function. Why it is a path function? I have talked about it in my previous class. It is a path function because if you are going from this state 1 to state 2, and if you are following say this path, okay, then your work done will be different, because the area under the curve, if it is like this, it will be different. So if area will be different in this curve from the curve drawn, then we will say that work interaction is a path function, because it is depending upon path, and hence it is depending upon the history, because you know that you are reached 2.2 or state 2, but what path you take, what is the history. So therefore work interaction is dependent upon path and history, and is an inexact differential, because if you integrate dw, you are not going to find w is equal to w2 minus w1, which are the limits of the integration. And work interaction is a boundary and transient phenomena, and you can understand this topic also clearly, because the energy transfer or work transfer is going on from the system and surrounding by a boundary, and therefore is a boundary phenomena. So let's see, so here are other 2 points also, let's quickly go through them. Non-flow work or boundary work or closed system work, this area enclosed by a PV diagram represents network if the PV diagram is having a cycle. So what is meant by this line is, let's say we have a PV diagram, pressure and volume, and in the PV diagram we have a cycle. So here is your point 1, here is your point 2, and we have this cycle going on, process 1 A2 to B1. So the area enclosed by this will give you network, because process 1A2 is in clockwise direction and the other point is written, all clockwise cycles on PV diagram represents work producing device, that is positive work will be done. And if work is done by the system, you will take it as positive. This is the standard for all the relations that we have calculated and we have just derived. So we will also use work done by the, we will always use work done by the system as positive and vice versa. And if 1A2 process is moving in this direction, then you will find that the area under this will be a positive area, will be the positive work done, and 2B1 will have negative work done because of the counterclockwise direction, and hence the net work done will be this area under this cycle, which will give us the net work done. So that was what written here in the 2 points combined. Now let's talk about the non-flow work in various processes. I will start by the constant volume process, and let's talk about the constant volume. Again, we have talked about the 3 processes in our previous class, but since we are going to use those 3 processes in this class also to do numericals, so I thought it is better to just go through them quickly once again, so that you can just have all this non-flow work processes formula in one place. So first one is the constant volume process, that is V is equal to C process, constant volume process, which is also called as isochoric process. So for constant volume process, you will have, what is the non-flow work formula? It is always going to be integration of PdV, and if volume is constant means dV will be 0, no changes in volume, and hence your final work done will be 0 for constant volume process. Therefore we can say that the work done is 0. So let me just adjust a camera a little bit. So let's continue our discussion. So a lot of you, just to inform you, since some kind of work is going on, more specifically my house is just home is just getting painted, so I have to just change my position a little bit from my usual position, and I am completely going to change the position to I am making a whole area with the green screen, so it is going to take some time, but you can expect this in coming days, and I think tomorrow or day after tomorrow it will be ready. So you will find that the video feed of mine will look a little bit more sharper and clearer due to that. So anyways, it is, I have also adjusted it so that it is looking fine here. The background is quite plain so that you can focus on the video feed properly. So let's continue our discussion. Our second process that is going to be discussed today for non-flow work, boundary work, is pressure is equal to constant and P is equal to C, or this is constant pressure. And constant pressure processes are also called as isobaric process, or isobaric process, or isopistic process. And isochoric process and isometric process are also the name of constant volume process. So just for your information, these are the names for the constant volume and constant pressure processes. And so work done, non-flow work done or boundary work done here will be, the pressure is constant, so it will be taken outside, and if you have this 1 to 2 that is state 1 to state 2, the process is taking you, then you will be finding that your work done is P, which is constant, V2 minus V1. And here the work done will have units joule, because you will find that this uh, PV is going to give you the units Newton per meter square into meter cube. So you will be left with joule. Third process is one of the most important processes in whole thermodynamics. We have PV is equal to C, and how we have obtained it, let's see. We have this temperature is equal to constant, or T is equal to C, and the post process is known as isothermal process. Sometimes it is also hyperbolic, because the curve of a T is equal to C in the PV diagram will give us a hyperbolic curve, because P and V are related by P inversely proportional. So this will give you a hyperbolic curve. So how we obtained PV is equal to C, I have discussed that also. So for ideal gas, so ideal gas will give you this PV is equal to nR bar T or mRT. So since temperature is constant and these two terms will be constant, so you will find that if temperature is constant, if T is equal to C, then you will find that PV is equal to C. Now we know that PV is equal to C for temperature which are constant. If ideal gas is there, then what will be the work done for isothermal process? So for isothermal process, we have same formula for, since we are going to calculate here also the non-flow work. So instead of P, we are going to write C by V dV, and hence we are going to get the work done after integration as V2 by V1 if we are doing this integration from 1 to state 2. So this is our work done. So work done, what will be the C here? C can be equal to, so first let me write this. And if you are taking, or if you are changing V to P, then you will find P1 by P2, because they are inversely proportional. And one more thing here that you should remember is that what are the assumptions that we have taken to get to this formula. We have taken closed system assumption, because we have this non-flow work which is also called closed system work. Then we have this quasi-static process which will be reversible here, and then you have the other thing which is ideal gas, from which you are getting this PV is equal to C. So the last thing, what is C? C can be P1 V1, it can be P2 V2, or it can be nR bar T1 is equal to mR T1, or C can be nR bar T2 is equal to mR T2. So these are multiple ways in which you can find C and use it to get this work done for isothermal processes. And assumptions also you have to remember. And again, the curve that is there in the PV diagram for isothermal process is hyperbolic. Why? I have discussed it. So let's talk about some other processes that we haven't talked about, and for that after that we will see what are the processes looking like in the PV diagram, but for that I will need a new page here. So let me just add a page or slide. So the next process, the fourth process for which we have to study the non-flow work or the boundary work is adiabatic process. So adiabatic process means there will be no heat transfer involved, and the adiabatic process is given by pressure into volume raised to the power gamma is equal to C. So this is very important formula that you have to remember for adiabatic process, and I hope you remember this since this is a revision class. So you must have studied this, and this is again the non-flow boundary work formula. And here if we are going to do the integration by keep using this equation above and putting this C by V raised to power gamma instead of this P, then we will find that work done is coming out to be P1 V1 minus P2 V2 divided by gamma minus 1. So this is our formula that is coming out, and this is for adiabatic process, and we have a reversible process, ideal gas. So this are nothing but what are the assumptions we have taken to derive that this formula. And the last process that we are going to talk about is, so let me check, I am keep checking this mobile application so that if anybody you have any doubts I can just clear it. So if you are if since nobody is watching it live, so I recommend you to watch this live, since then we can discuss this more properly. So the next is polytropic process. So this is the final type of process that we have to study, and for polytropic process we have this formula that is followed by the process, and here n can be anywhere between minus infinity to infinity, but generally it is this, that is it is between 1 to gamma, that is the polytropic process curve will be if we draw all the processes curve, we will find the polytropic process curve between the isothermal and the adiabatic. So work done similarly you will find it as P2 not P2 V2 P1 V1 P1 V1 minus P2 V2 divided by n minus 1, and this is for closed system, polytropic process, closed system, and reversible process. So these are the assumptions using which we have obtained this formula, derived this formula, and so yes, that will be it. And this is polytropic work done, so always remember that the work done is polytropic. So now we have discussed about the non-flow work in various processes, and we have also discussed about the what the non-flow work actually is, what are the curve of a non-flow work, diagram of a work represent. So now we are going to talk about the PV diagram of ideal gas that we are going to find for these processes that we have discussed. So I've written here some points that I have to discuss, some very important points. So I am discussing this, and I will be sharing this point, which are some important things. So let's move on. First one is isothermal. So for isothermal process, what your PV diagram looks like, it looks like this. You have your state 1 and you have your state 2, and this is the hyperbolic curve, and this is the direction from state 1 to 2. And if you draw here a slope, you will find that this slope will be having the angle, the slope will be negative, and this angle theta will be greater than 90 degree. And what is the slope, exact slope of isothermal process? For isothermal process, you have this PV is equal to C. If we just differentiate this, we will find P dV plus V dP is equal to 0. So from here, dP by dV, which will give slope of this isothermal curve, it will be minus P by V. So again, this minus sign represents that the slope is negative, so theta will be greater than 90 degree as written here. And this is what isothermal curve looks like. And then we will have, because constant volume and constant pressure process are very easy to draw in PV curve, so I am not going to draw that. I am next going to draw adiabatic curve, and adiabatic curve will be, so for expansion you will have state 1, you will have state 2. So from state to 2, from state 1 to 2, for expansion you will be having this curve and this curve. I should draw it more properly so that my point is a little bit clear. So the upper curve is T is equal to C isothermal, and the bottom one is adiabatic. Why the adiabatic curve is having more slope? It is quite easy to see because this is the adiabatic formula, and if we just differentiate it like the one we did here for isothermal, dP by dV will be obtained by P by V minus, but this time we will have a gamma here, and this gamma here will make the slope steeper. So slope of adiabatic process is steeper than isothermal process. So I hope you are able to follow why the slope is getting steeper. And for compression process, we can also draw the same thing. So if compression process is there for PV diagram, you will have your adiabatic process as this 1 to 2, and your isothermal process will be having a less steeper slope, so it will be like this. So this is your adiabatic, and the bottom one is your T is equal to C isothermal, because the slope of the adiabatic curve will be more steeper. Why? Because we have seen the dP by dV value is greater for adiabatic and less for isothermal because of this additional gamma term which is coming when we differentiate it and find the curve. So one more interesting thing that I am going to draw here, which will let you compare about this different processes PV diagram. So before doing that, let us draw a table from which we can see this. So we have this value of k. So let's take a term k, and we have processes name. So we will have 5 processes here, which we are going to talk about right now. So the first process will be for k value 0, and this is what k is. So k is the exponent here, power here, and it will be is equal to c. So if k is equal to 0, what we will be obtaining? We will be obtaining P is equal to C. So the process will be constant pressure process. And then we will have k is equal to 1. So PV is equal to C. It will be isothermal process. Then we will have this N, because N is generally between 1 and gamma. So if PV raised to power N is equal to C, then we will have polytropic process. And this will be adiabatic. And then we will have infinity. If V is equal to PV raised to power infinity is equal to C, then if you just remove the infinity, you will going to find that you have this constant volume process. So these are different processes, and by using this thing we are going to draw here PV diagram for expansion and compression. So let's first draw it for expansion. So here we have this k is equal to 0. This is giving us constant pressure. So this line is constant pressure, and this is for k is equal to infinity. This will give us the constant volume. Then we will have this, this, and this. So what will be the topmost curve here? It will be, and it is generally following 0, then it will start increasing. So we will generally have this 1, n, and gamma, since they are in this order. So 1 will be your isothermal, n will be your polytropic, gamma will be your adiabatic. Again, isothermal and adiabatic, you can see the slope is steeper for adiabatic, and this is for expansion. But let's draw the same thing for compression here. So constant volume will be straight line, it will be horizontal line for a constant pressure. So it will be 0, k value, it will be infinity. Then we will have this 3 curve, and it will be 1, n, gamma in this increasing order. And what processes they are for, I hope you can understand here. So here notice one very important thing, that the area under this process, this where k is equal to 0, that is constant pressure process, is the most. So work done will be maximum for this process, because the area under this being the most. So maximum work here due to area under this process being maximum. And I hope this is very clear. We have talked about it before, that area under the curve of a PV diagram, a process which is having going from 1 to 2 or any state to other state, will be giving us the work done, and the area if more, we will have more work done, and therefore you can just see why the work done will be more for this constant volume processes. So let me check if the video stream is working properly or not. Yes, it is working properly because I thought it got stuck. So let's move forward and do our questions here. And I have some more things to discuss here, but I will be doing some questions, then we will come to that and discuss those things. So the first question of the day is match the following. We have work done, thermal equilibrium, internal energy, no work and heat interaction, and we have to match this with point function, path function, isolated system, equality of temperature. So the first work done A, and it will be path function because I have talked about it. It is going to be a very important point for the work done process, that which path is followed by taking it from point 1 to point 2. So A will be 2. Thermal equilibrium. So thermal equilibrium is important for equality of temperature because thermal equilibrium itself means the temperature should be equal, then only thermal equilibrium is reached, and therefore equality of temperature is thermal equilibrium. Mechanical equilibrium is equality of forces, and chemical equilibrium is when you are having this so I think the power is here low, so let me just quickly go and switch on the plug there. So apologies for the little bit of break there. I just forgot to switch on the power. So what we were discussing, yes, mechanical equilibrium is equality of forces, and chemical equilibrium is when the chemical compositions is not going to change with time. And when we have a phase equilibrium, that is the mass of the phases will remain same as with the time. So internal energy, it is a point function because energy is a point function. That means it is not dependent upon path, and only the final and initial states will be required or will be important when we are talking about energy changes. So C will be 1, and finally we will have no work and heat interaction, so it will be isolated system. D will be 3. So this is the correct answer to this, and I hope you can follow each and every point why this is no work and heat interaction, that is isolated system, and plus in isolated system there will be no mass interaction also, that is no mass transfer also. So this is the match the following, and the correct answer is A2, B4, C1, D3. The next question that we have to do here is a system containing air undergoes a change of state from P1 V1 to P2 V2, whose values are given in the question, the P1 and V1 values respectively. The process undergoing or undergone by the system is, and here the options are provided, and we have to find what this process is, and for that we have this processes P is equal to C. So let me write it properly here so that you can. So for isochoric process we have V is equal to C. Isobaric process will be for P is equal to C, that is constant pressure. Again, the ink here is very much not suitable for writing. It is better on the Unacademy's website. Isothermal is T is equal to C, and this will give us PV is equal to C. Isentropic process is entropy constant. So we have not yet studied about entropy. So constant entropy. So let's see what we have here. So for this process, is volume going to remain same? So no, volume is changing. We can see from the data itself. So A is not going to be the answer here since volume is changing. And isobaric is not going to be the answer since pressure is also changing. Then we are left with isothermal and isentropic. So let's check. We have no way to check if temperature is changing or not from the data that is given in the question. We have to find the temperatures there, or we can check if the product of P and V is constant or not, because for isothermal process for ideal gas, since we have this air and air is assumed as ideal gas here, then we can see if this P and V product is constant or not, and if it is coming constant, then we will say that this is a isothermal process. If not, then we will be left with this isentropic option to select. So P1 V1 is equal to 0.5 megapascals into 0.287. So I'm just writing the value here. It is coming out to be 0.1435, and I'm not going to write the units here. It is units. And then we have this. So this is specific volume that is given. Just see, this is kg. Then we have this P2 V2, which will be 0.1 into, yes, it is also coming out same because 0.1 into 1.435. We can say that it is also same. So you will have PV is equal to constant you are getting. So your process will be the isothermal process due to this. So constant entropy, we don't need to check that because we have already obtained the correct answer. Pressure and volume product is coming constant, so temperature is constant, and therefore we can say that this process that is undergone by the system is nothing but a isothermal process. So nothing but an isothermal process here. Again, if you guys are, or if you girls and guys, students are watching this class live, or if you are watching this recorded, then make sure that you are attending this classes live so that I can ask questions and you can also interact in a very good way. And if you have not subscribed to this channel, then make sure that you are subscribing to this channel, and make sure that you are also clicking the notification icon so that you can get this channel send you notification whenever an educator goes live, so that you can attend his or her class live. And also I am taking classes on the Unacademy's website, which you can follow me on the website, and the link is on the screen, so just write it down. It is unacademy.com/user/19abmi-9136. You will be taken to my profile where you just have to click the follow button, and you will be having all my schedule, all my notes, all my classes that I am taking there, and attend that classes and use the code ABHIMI in all capital letters so that you can watch free classes there. So the code is you can see on the top of the screen, the code is there, ABHIMI, to watch free classes on the website and app of the Unacademy. And let's do the question here. An ideal gas expands isothermally from a volume V1 to V2, then compressed to original volume V1 adiabatically. Initial pressure is P1 and final pressure is P3. The total work done is W. Then we have to compare the final pressure and initial pressure, and what is the work done. If it is 0, positive or negative, we have to just inform and provide the answer with that information. So let's draw PV curve, and we have discussed a lot about PV curve, and I hope this PV curve can be drawn properly by you all. So for ideal gas, we have first going from process 1 to 2 in a isothermal way. So isothermally the gas is expanding. So if the gas is expanding, then volume V2 will be greater than V1, that is for sure, because of the expansion we can say that. So we will have one process here, other process here. Since isothermal expansion looks like this, if volume is increasing, your pressure will be decreased, since this is T is equal to C isothermal process. Or let me just write PV is equal to C. So you can say, since we know that V1 is less than V2, so P1 will be more than P2, because PV is equal to C, that is pressure and volume are inversely proportional. So we will have this V then it is compressed back to original volume adiabatically. So let's draw using other pen here. So we have to go to the same volume V1, which will be volume of V3 also, which is given in the question. This we have to do. So our final process will be in this line, and this is V2. So the process is going to be compressed adiabatically, therefore the slope will be more. So we are not going to follow the same path to get to the same volume, but we are going to follow a path which will have a steeper curve than the isothermal process. The path is adiabatic, and this is the curve. It is 3, and this is adiabatic. So adiabatic process means PV raised to power gamma is equal to C, and this we have also studied. And just see here that the final pressure is greater than the initial pressure. By looking in the figure only, you can see that this P1 will be less than the P3. So A or C will be the correct option. Then what will be the work done? To do the expansion process 1 2, we will be producing work, and that work that is produced will be the area under the curve 1 2. And to compress, we have to give work to the system, and therefore that work will be negative for the system, and the area under the curve 2 3 is more than the area under the curve 1 2. So we can say that the work that we are producing from the process 1 2 is less than the work that we are requiring to compress the system to in the process 2 3. So therefore the total work will be negative due to the work producing being less than the work uh, taken as input for this compression process 2 3. So it will be C option, which is telling us exactly the thing that we have discussed, that final pressure P3 will be greater than P1. You can see it in the figure, and W is less than 0, because we are overall taking work to reach the state 3 from the state 1 by doing process 1 2 3. Network output for the cycle is, and we have to draw a cycle here. Then that cycle you have to, I'm going to draw, then you will provide me the answer what will be the network for the cycle. So we have a PV diagram here, pressure volume diagram, and in this diagram, let us take this as 2 3 4 2 3 4. So it is a little bit wrong I have drawn here. So you have your process A, B, C, D, E, F, then A. So that is what is given in the question. And here you have to find the total work output for the cycle. And options are given below, and here also you have some values. And let me just provide it. It is kilopascal here, and it is meter cube here. So net work output will be the, let me show you the 2 points that I have talked in the start of the class, so that you can use that 2 points and to do this question. So area enclosed by a cycle on a PV diagram represents the network interaction during the cycle. That means if we have to obtain the network for a cycle, then we have to look no way other than just the we have to look just at the area enclosed by the cycle on the PV diagram. And remember, clockwise cycles on PV diagram represents the work producing devices, engines, and vice versa, work consuming devices are the ones having anti-clockwise direction. Clockwise direction, work producing devices, therefore positive work, because system if producing work will be taken as positive, because that's how the sign conventional we are following. And then we will have a work consuming devices where work is given as input as negative work. The area will be negative there because of the way we are deriving this, and we are taking the standard plus and minus sign for the processes. So here we have, in this process we have two cycles, and just see the first box or the first cycle, the first rectangular cycle. And if I take this as, if take this as O, this point, then ABOF, the area there will be positive because of the clockwise nature direction of that cycle. We will be getting positive work done. And this will be negative, and both are exact because the dimensions are same. Here it is clockwise, here is counterclockwise or anti-clockwise. So the work that is done by this ABOF in positive, the same work will be consumed by this CDEO for cycle, and this plus and minus will give the net work output this of this cycle as 0. That means how much work is produced is just also used, so you are not having any network output obtained in the cycle A, B, C, D, E, F, A. And we have used the concepts that we have discussed in this question only. So again, this is revision class, and I am making sure that not only we are going through the topics, going through the concept, we are also applying this, so that we can have a proper grasp at this topics, and we can understand this proper in a proper way and in a better way. So I hope this concept is clear for all of you. And let's move forward and do the next question, which is also be involving a PV diagram. So here we have to find the network done for the closed system shown in the PV diagram, and for that I think I have to draw a PV diagram. So let me just see if my question paper written here, what is the diagram. So yes, we have this diagram here, so let me draw it. Volume in meter cube, pressure in bar. Six, 4, and we have here 1. Then we have 2 and 6. So A and B, it will be like this. Then we have this BC process. CD process. So what will be the net work done here for this closed system, since this is closed cycle, and we will have to find net work done. And what is the net work done? Net work done is nothing but the area enclosed by the cycle. So we have to just find the area here and give the answer in the proper units. So I will do this question here only. So what is the area of this ABC triangle and ADC triangle, or if you know this AB length or BC length, then also you can do, but we are going to find the areas of these two triangles, which are, by the way, this is your 2 and this is your 3. So just see, they are not similar triangles. So triangle ABC, so triangle ABC will have area equal to half into base will be 4, into height will be 2. So it will be 2, no, not 2, 4. And then we have this triangle CAD, which will have area equal to half into what is the base here? It is similarly 4. Then we have height 3, so it will be 6. And therefore the areas 2 combined will be 10. So total area will be 10 units. And if we have to find, we have to convert this into, this unit will be bar into meter cube. So we will convert this into kilopascal into meter cube to get our answer. So work done will be, therefore work done will be 10 into 100 into, and the units will be kilonewton meter. So it is going to be 1000 kilonewton meter. That is option D. That will be the correct option here. So I hope this question is also clear, and I don't have any answer key, but I think this is the correct answer. That is quite simple, so I don't think we require the answer key here. So we just did 2 questions from the topic this PV diagram, and we discussed a lot of PV diagram things, curves. So let's continue our discussion, and let's do this other question. So for today, what we have this 2 questions left, then we will end this class. And again, we talked about a lot today, and we will see if so we have the other things that are left are after this for the basics before start talking about first law of thermodynamics, or we will see, and we will talk about first law of thermodynamics and heat in the class that we will take tomorrow. And again, I am taking the class at unacademy.com or Unacademy app. So you can come here there and attend the class, and that class will be going to take place at 10 p.m. today. So make sure that you are coming to that class and just spending that 1 hour by doing the questions. And so again, today's class is important questions thermodynamics at 10 p.m. A certain amount of an ideal gas is initially at pressure P1 and temperature T1. First, it undergoes a constant pressure 1, 2 such that T2 is equal to 3T1 divided by 4. And then it undergoes a constant volume process 2, 3 such that T3 is equal to T1 by 2. Ratio of final volume to the initial volume of the process is what we have to find. That is ratio of final volume and the initial volume. So let's draw a PV diagram so that we can have a clear look of what is occurring in this whole processes that is given to us. So this is P, this is V, pressure into volume diagram. Initially it is at P1 and T1 and it is undergoing then constant pressure process 1, 2. So we will have temperature of the process. So in the constant process, so this is very good question here. So P1, V1, T1, and it is going constant pressure process. P is equal to C, constant pressure process 1, 2. So P2 will be same P, but what will be the V2 and T2? So since we have this PV is equal to MRT, or PV is proportional to temperature, so we will say that if P is constant, our V will be proportional to T if P is equal to constant. And therefore if temperature is increasing, our pressure will increase. If temperature is decreasing, if temperature is increasing, our volume will increase because pressure is constant. And if temperature is decreasing, our volume will decrease because temperature is proportional to volume and pressure is constant. Then we will get this. So temperature is clearly decreasing. So we will say that for this constant volume process, this is 1, this is 2, volume will be decreasing because of the temperature being decreased. Then it undergoes a constant volume process, from constant pressure process to constant volume process. And again similarly, if V is equal to C, then we will find pressure is proportional to T because PV is equal to MRT. And if from from state 2 to 3, in the process 2, 3, we are having the final temperature T3 equal to T1 by 2, which is less than this 3T1 by 4, then we will have this pressure decreased. Ratio of final volume to initial volume means we have to find V1, V3 final volume divided by V1, or we can also say V2 divided by V1 because these two volumes V2 and V3 are equal. And here let us see what is V1 first. So V1 in terms of T1 will be MR T1 by P1. And V2 will be MR T2 divided by P2, but P1 and P2 are equal. So if we divide V1 V2 by V1, V2 divided by V1, we will find nothing but T2 by T1, and T2 is equal to 3T1 by 4, and the T1 will be there. So 3 by 4 will be the ratio of final volume to initial volume, which is coming as 0.75. So V final by V initial is coming out as 3 by 4, which is what was asked in the question, and which will be 0.75. So this is the processes 1 to 2 to 3. So let's do the other question here. This is the final question of the day. Air is held inside a non-isolated cylinder using a piston which is having mass 25 kg, area as 100 centimeter square, and stoppers of negligible area as shown in the figure. The initial pressure Pi and Ti of air inside the cylinder are initial pressure and temperature are 200 kilopascal and 400 degrees Celsius respectively. Ambient pressure P infinity and temperature T infinity are 100 kilopascal and 27 degrees Celsius respectively. Temperature of the air inside the cylinder at which the piston will begin to move is what we have to find in the question, and the figure is drawn in the bottom part of the slide here, and you can see that this question is one of the best questions in GATE examination, because here there are multiple ways a student can make mistake. First is G is to be taken as 10, not your usual 9.81. The other thing is here your this let us discuss that other thing while we do the question, because that will be better way to do that. And let us do this solution in a blank slide here. So first of all, what we have to find, let us write temperature of the air inside the cylinder at which piston will begin to move. And what we need to be doing is we need to copy this. Temperature of the air inside the cylinder temperature of air inside the cylinder in degrees Celsius we have to calculate, for which or at which the piston will begin to move. And if you know the solution to this question, you can post it or write the answer on the comment section. So let's do one thing. Let's erase this, because I think it should be better if we just do the solution there, because it was taking a lot of space. So first of all, I am drawing this piston here, or let us draw in this figure only. So we will have this mg by A acting at the bottom direction, P inside and P ambient. And it would be better, I think, if I draw the piston here separately. So this is one of the pressure that is acting. This is other pressure, P inside, P ambient. So since we have to move the piston and we have the stopper here, so these are stoppers. So these are your stoppers and we have to move the piston. So your stopper will not allow the piston to move when it will go up, because it cannot go up because of the stoppers. So you will have to make the temperature such that piston begins to move in the bottom direction, and piston will move in the bottom direction when this inside pressure of the piston will become equal to the pressure which is at the outside, that is ambient pressure, plus the pressure that is due to the weight of the piston. And pressure initially, that means, will be higher than the pressure that we are going to calculate for the final state of the system. So initial pressure is 200 and initial temperature is 400 degrees Celsius, and that initial pressure needs to be decreased so that the ambient and the pressure due to the weight just makes the piston move in the bottom or in the downward direction. So that pressure will be equal to, or the final pressure will be this inside pressure, which will be the final pressure. This is going to be equal to, so when this pressure of the inside region just become equal to the ambient pressure plus the pressure due to this mg weight divided by this area, then the piston will start moving in the bottom direction or in any direction, and the bottom direction is only direction in which it can move. Ambient pressure is 100 kilopascal and we have our mass 25, our acceleration due to gravity 10, area is 100 but it is in centimeter square, so 10 to the power minus 4. Here it will be in and we have to divide it with 1000 also to get this whole value in kilopascal. So the final pressure in kilopascal, what it will be? It will be 125. So final pressure is coming out 125, which is nothing but the sum of this ambient pressure and the pressure due to the weight of the piston. And we know that the volume will remain same during this process because still the piston pressure reaches this 125 from the, so pressure initial goes to pressure final. So pressure initial is 200 kilopascal, it is 125 kilopascal. So till the pressure reaches 125, our volume will remain constant due to the stopper. So that means that P is proportional to T for ideal gas, since volume is equal to constant till 125 kilopascal pressure. After that your piston will start moving bottom direction. So your P is proportional to T, that means P1 by P2 will be equal to T1 by T2, and this will give us the value of T2. And here remember that while writing this T1 you have to convert this T1 into Kelvin. It is given in 400 degrees Celsius, but the ratio is not taken as 400 degrees Celsius. We have to convert it into Kelvin. So what will be the 400 degrees Celsius? It will be 673 kelvins, and P1 is 200, P2 is 125. So your T2 will be this value. So T1 673 divided by this value, so it is coming out as T2 is coming out as 420.625. So let me write it somewhere else so that I can properly. So 420.625 Kelvin, but we don't have to write the answer in Kelvin, we have to write the answer in degrees Celsius, and this is one of the things that a lot of students made error in. It will be 147.625 degrees Celsius, and this will be the correct answer. And if you are not using G as 10, if you are using it as the standard value without seeing the question, 9.81 if you are using for acceleration due to gravity, then you will be getting different answer, and it can come outside your range, and hence your answer can be wrong. And again, if you have just calculated this whole thing in Kelvin and written the answer, then also you will be getting the wrong answer, because your degree Celsius is the one unit, that is the unit in which you have to give the answer. And if you are using this temperature as 400 degrees Celsius in this relation, in this equation at the bottom, the final equation which is providing us the answer, then also you will be getting this question wrong because of the error done there, because the ratios are taken in Kelvin. So there are multiple ways in you can do the question wrong, and you have to be aware of each and every of this potential errors so that you can avoid them. And again, just check the unit before giving the answer, as I am telling you again and again. This is one of the best ways you can do this less mistake or avoid this mistake. So that's it for today's class. We have discussed quite a lot of things today. And again, if you want to follow me, then you can follow me on unacademy.com. Here is the channel Unacademy, my profile link, that is unacademy.com/@19abmi-9136. And while if you are following me there, then you will be getting a lot of classes that I am exclusively taking there, and you can use this code ABHIMI to get free classes, to watch free classes, to get the notes, free notes that I am teaching from, that I am teaching using the questions, the theory on the Unacademy website, by visiting my profile and follow me there to get the schedule, and so that whenever I take classes live, you can get a notification, and this will make you not miss my class and come there live, which is the best way to attend a Unacademy class or online class. And subscribe to Unacademy if you haven't already. Hit the bell icon so that you can get notification whenever an educator goes live, so that he or she can take live classes and you can attend his or her live class and interact there very in a proper way, not like the recorded session where you have to just watch it and move on, and hence you cannot ask the doubts while the class is going on. And hit the like button if you found this class helpful, and if you found this class engaging, beneficial, and if you want me to continue the classes like this only, and that will help me a lot. And use this code to get the Unacademy subscription on 10% off. That is the least possible price. The prices of Unacademy subscription are very reasonable. And again, I am pointing this, that subscribe to one of the Unacademy subscription plans, because a lot of crash courses, revision classes are starting right now, and this is your chance to attend them live and to take most out of them, to learn most out of them. And during this time, join the Unacademy subscription, give test. The subscription will also let you give test that will be similar to your GATE exam. So join a test series, do revision by attending revision classes, give test, and then again see the GATE question paper official from their website. So do these three things in this last 2 months, and you will find that you are. So that's it for today's class. Thank you for watching. Best of luck for your preparation, and stay safe, take care. That's it for today's class.